What happens if we say something funny?
Whiffletrees!
Hello and welcome to the Hackaday Podcast. I'm Elliot Williams.
And I'm Kristina Panos.
This is episode 33.3 times 10. Nightmare Whiffletrees, 18650 safety, and a telephone twofer. This week in Hackaday news, get your tickets for Supercon now. They've been on sale for a week and a bit. Early bird tickets went super quick as usual. Regular tickets are still on sale and they're still a bargain. You get all your meals. You get an awesome Halloween party. What more do you want?
Get your tickets, get them while they're hot.
Exactly. We'll be announcing talks pretty soon. Looking forward to seeing everybody early November in Pasadena, California. It starts on October 31st this year. That's how early in November it is.
Yeah.
It's so early November this year that it's in October.
But is it still daylight saving time weekend?
Oh no, is it still gonna? Yeah, right?
November 2.
Oh, superb. For those of you who don't know, we somehow managed to always have Supercon during the daylight savings time change weekend. So the good news is we always get an extra hour of sleep that one night. So it's actually kind of helpful. We've accidentally managed to have the European one, which is in the spring, also on daylight savings time change weekend, but it's an hour in the other direction, so it sucks. See, we don't actually plan around it. It's always a surprise to see if it happens, and damn it did yet again. What else? The One Hertz challenge ends on Tuesday. If you have a project you'd like to enter, no matter how big, no matter how small, anything cool that does something once a second, whether that be precise, imprecise, ludicrous, funny, even just blinky, we don't care. Once a second, whatever it is, we'd like to see it. And last up in the kind of newsy news, end of the eternal September as AOL discontinues dial-up. And the news to me here was that AOL still had dial-up? What?
Apparently.
That's crazy. So Jenny wrote this up. According to her write-up, 0.2% of Americans are still on dial-up. AOL, I guess, isn't serving you anymore, but there are other dial-up services if you need them.
Well, that's good.
We're not on dial-up, but we're on DSL, so
Oh.
I can't talk too much trash. I know.
No, you cannot.
Everyone else is on fiber, right?
Probably. I am. Oh, I'm on Google Fiber.
See? We had a petition in our neighborhood, actually, to get fiber, and if 1/3 of the households signed on, the company would have been contractually bound to run the cable, and we didn't make it.
Oh.
We got 23%, so... It doesn't mean they won't, but it means they're not required to. So, no fiber for me.
Oh.
We'll survive.
Okay.
Who needs the internet anyway in this day and age? Oh, that'd be me, actually, because I need to upload the What's That Sound?
This is a journey into sound.
What's that sound?
What's that sound?
This week is a Guess the Sound week. That means we'll play a surprising sound in a few seconds. Kristina will have a guess at it, and then you at home can give it a guess and be in the running next week for a Hackaday Podcast t-shirt.
Oh, here it comes. Oh, that's a coin counting machine, probably, or something.
Not a bad guess.
Oh, okay.
That's a very good guess. I'm writing that down for my future one.
Okay.
Second guess? Coins isn't far wrong.
Otherwise it sounds like it's pumping dog food and then releasing it into a bowl.
Super. You were closer with coin machine. Well, if our listeners out there have a good guess, head on over to hackaday.com/podcast. Scroll on down to What's That Sound, fill in the form with your handle and your best guess, and we'll see who gets it right next week. It's,
Oh.
Well, my first hack this week, well, it's kind of more a story. Joseph Prusa warns, open hardware 3D printing is dead. This was like the most comments and the most, the most controversial news story this week. Joseph Prusa of Prusa 3D printers, is claiming that the end of the open source 3D printer era is dead because companies now are in the 3D printer space are all stockpiling patents against each other and trying to protect their little niches using patents. And in particular, he throws a bunch of shade at the Chinese companies doing that and suggests that they have incentives to file lots of patents because they get basically kickbacks from the government for doing so. Either way, it's a lot cheaper to file a patent in China than it is in the US or Europe. And he's afraid that this over patenting of a lot of the technology in 3D printers is going to have a chilling effect on open hardware. I am not 100% so sure, and I fear that some of this is that Prusa has seen the business switch from, the 3D printing industry used to be, first of all, it was only hobbyists when I got in, and then there were a few companies that tried to make some money on it, and then fast forward to today, it's global business and kind of a normal thing, and we're kind of in this like third phase where everything is mass market and the competition is among larger companies that are all trying to make their 3D printers more easy to use for people who aren't kind of 3D printer enthusiasts, for people who just want to print something, for people who maybe, I'm not going to say it, I'm going to say it, aren't Hackaday readers or listeners, probably. I think they're just trying to make it so that, so that your parents can get a 3D printer.
Oh, not my parents.
No? You don't think?
No.
All right. Well, my son has a 3D printer and has since he was 10. And
Wow.
I promise you, they're good enough these days that you can teach a 10-year-old how to slice things and print things on his own. That certainly is a testament to the status quo in 3D printing right now. We're at the consumerization phase. We're at you can just give it to somebody, give them a little bit of instruction, and they can go off and do it. And I think that's awesome. I know a couple years ago, there was kind of a race to the bottom. Everyone was trying to make the cheapest printers possible. And I think Creality probably dominated that phase. Bamboo is now moving on with, to my tastes, incredibly expensive printers, but printers that just kind of work. And that is pretty cool too. They're also blazingly fast. They do this though on the backs of all of the open source designs. So, the mechanics is basically they learned from the Voron printers. The software side is all Clipper and the pressure advance and motion compensation stuff coming out of that. I mean, it's funny to say that open hardware 3D printing is dead when all of these dominant 3D printer companies are basically making what to me seem like funny little patents on the fringes of community developed hardware designs. So I don't know. If anything, I think all of the community's hard work has kind of paid off in a way, and a bunch of companies have taken our essentially free research and development and commercialized on it. And I'm not sure if that's a good thing or a bad thing. I mean, I think it's awesome. At the same time, every week here on Hackaday, we see crazy new 3D printing developments. Like, I kind of try not to pick 3D printer stories because we pick them so often. We sound like a broken record, but like last week we had an amazing 5-axis 3D printer and slicer suite that just, you can't buy something like this. This week alone, we had someone working on continuous path 3D printing, not traditional vase mode where you do something that's obviously a circle printed in one spiral, but taking actually complex shapes and doing the path planning so that you can do it in basically one extrusion through the whole thing. In this case, it was to make it a clearer case. It was made out of transparent, but if you don't do retractions, the filament comes out clearer and it looks better. I mean, that's the whole reason for the hack. Yes, it is. And, we also had an automatic filament changer that Layer Lab was working on, where instead of doing 2 different colors or 2 different types of filament, they just want to be able to load up 2 spools and have the machine change halfway through, burying the change on the inside of the print so that there are no visible changes when it switches between one roll of filament and the other. I mean, there are all these things that hacker types are doing to push the edges. And so I think what Joe Prue probably means this is that it's getting harder and harder for him to do business. His old business model used to be kind of putting out a really premium printer based on the open source innovations. And now that the Chinese firms have kind of bifurcated, right? Like there's some that are making super cheap but yet pretty reliable printers, and there are others that are making high-end and, just turnkey printers. I think it's harder to see where Prusa fits into this thing, and I think his business is personally feeling squeezed out by this. So in that sense, I understand what he's saying. And certainly Bamboo doesn't contribute back to the open source community as much as Prusa has. From a we should support the ones who contribute back standpoint, I think that's a reasonable reason to be concerned. But hackers gonna hack. We're just gonna keep on keeping on. And unless you are personally an owner of a 3D printer manufacturing company, you shouldn't be concerned about any of this. But we'll see. His argument is that these patents that are being filed left, right, and center now will, in kind of the next 3 years, 5 years, come due, and the companies will start patent trolling on them. And maybe that's true. I really hope it isn't. And also, it's trickier to enforce Chinese patents in America than it is to enforce Chinese patents in China. So if it does anything to the industry, it may actually just kind of concentrate the Chinese manufacturing down to a smaller number of firms if they start infighting against each other and taking each other out. So it may be harder for Chinese firms to continue to be innovative in the future because of this patent stockpiling. And maybe that's going to happen. I don't know. But I think for consumers of 3D printers, I think the future's looking good. For people who just want to hack on 3D printers, none of this is relevant. So I don't know. From a Hackaday standpoint, I say nothing burger. That's my hot take, though. That's a moderately warm take.
I believe I agree with you.
What 3D printer do y'all have?
We have a Taz 6, a Lulzbot Taz 6.
Oh, sweet.
That's the one that we use the most. The other ones, I'm not sure the condition of them, if they're up or not. I don't run them.
Yeah,
I let my husband do that. He's taught me, I know how to run them and stuff. I know how to do things, but I even know how to use OpenSCAD a little bit. Enough to be dangerous. But, yeah, I leave that to him, mostly. I still want my own, though. Because that's how I need to learn, is just, everything on my own.
Yeah.
But that's me. For my first hack, I chose James Brown's Talking Robot uses typewriter tech for mouth. Now, a little bit of background here. The IBM Selectric Typeball that this is modeled after was a marvelous invention that paved the way for printers with its clever digital-to-analog converter system. The semi-spherical metal ball is rotated and tilted by a mechanism called a Whiffletree, and if you're unfamiliar with the workings of the Whiffletree, which you probably are, be sure to check out Bill Hammack's excellent video on the topic, which someone linked to in the comments. When James Brown wanted to create a robot that appears to talk, he turned to the Selectric Typeball's marvelous engineering to create this plastic ball with several mouth shapes. Pivoting the ball rapidly inside the head in concert with recorded speech creates the illusion that the robot is talking. I think as cool as it is creepy, and I particularly like, the fact that the eyebrows match the mouth color, but the way that the mouth makes it look like he's got a little like Homer Simpson 5 o'clock shadow surrounding the mouth going on. I think that's cool. I don't know. It fits this robot's face very well. And I don't know. I think this was just, you must watch the video on Mastodon. You must. It's fantastic. It's nightmare fueled, but it's fantastic.
I can't tell which I think is cooler, the finished one where he's got the face built around the mouth, or the like just disembodied ball one where it's got this, like you say, Selectric typewriter ball with a bunch of different mouths printed on it. It's absolutely hilarious. It's really shocking how well the illusion works even when you can see the whole ball and you can see it moving, because it's precise enough that it actually like swaps the next one fast enough into space that you do think it's moving, even though you see behind the curtain, but still the illusion works. It's pretty damn cool.
I wonder if it was harder to build the mechanism because, or easier because of the way the center row is offset. Because on the Selectric ball, nothing is offset. It's all columns and rows that are ordered in a grid. So maybe his mechanism works diagonally.
I mean, if you want to put a bunch of circles as close as you can to each other, you kind of do this hexagonal stacking thing, right? You don't put them like you do in an egg carton where they're all like, or like a Selectric ball. You know, you fill up a little bit of the diagonal space, and I think he's trying to do that with it, right?
But maybe it works diagonally. Maybe there's just tilt. Well, tilt and rotate, but it's like the tilt is diagonal instead of skipping the middle, you know?
Right. Do we have any insight into I mean, there's the one about the Selectric typewriter. Do we know anything about the crazy mechanism?
Lewin says we don't get a great look at the mechanism that operates the ball.
Right.
In this case. So.
Yeah, I agree with that. That's so bummer. Maybe later we can hassle James Brown, if that is his real name.
Yeah.
Into showing it to him. Like, you'd think some names were taken. Oh no, that's so cool though. Well, next up from me, a marvelous project by Angelo and Oscar V. Hacking printed circuit board to create casing and instrument panels is kind of just one aspect of this project. This project is to make the PDP1, which is a clone of the PDP1, which is kind of the grandfather of all of computers and hacking culture. I mean, it's not the first computer, but it was the first computer on which a video game was played. Space War. It's the first computer where there were graphics demos because it had a nice phosphor screen and you could write to it. It was the first computer with a text editor. It was the first computer that did time sharing, had a debugger, connected to the ARPANET, computer, 4-part computer music. I guess there were other computers doing music prior to that as well. So, you know, it's not first, but look, the PDP-1 is where a lot of what we think of as kind of computer culture started. I think it's awesome that they're doing this rebuild. Inside, it's a Raspberry Pi, but the PDP-1 had this great, like, 60s industrial design, and they kind of wanted to reproduce some of that. But if you go look at any of the old pictures, it's this fancy blue and white, really like space age looking setup, basically. The full kit back then weighed 730 kilograms, 1,600 pounds, cost $120,000, which is kind of $1.3 million today. And only 55 of these machines were made. So basically, unless you were at MIT or some of the other research labs that had them, you didn't get to see one. The question is, how can we make affordable and, you know, how can they make it accessible to people in the modern age? Clearly, the computing power is not at all a problem anymore. Any microcontroller will dwarf this thing in a pure out speed race. So it's all going to be about making the switches that you have to flip to program it and making the case look good. They do that here by using printed circuit boards. And so they get a bunch of PCBs milled out to serve as the case. And what's really neat is they document how they assemble these kits and all the rest of it. And it's a really nice design, and they really kind of make the case for getting your object's case made out of PCBs. And they have a video that you should go check out if you're going to try to do this. They, first kind of put it all together, tape it, tack solder some of the 90-degree joints, and then once it's kind of basically stable, then solder all the rest of them. This is actually really clever because if you've ever tried to do PCB sculpture or whatever, you find out that solder contracts as it cools. And so if you try to make a 90-degree angle, if you just put two PCBs at 90 degrees and you run a solder bead down there, as it contracts, it pulls it over. So you get kind of 89 degrees or 88 or something. It's horribly frustrating. And their procedure here makes the case in kind of one shot. So it pulls itself together, if anything. But of course, everything's butting up against other pieces. And so it stays square, which is pretty cool. Probably makes it super stable, actually. The other thing they do that's really cool is the tabs that need to be soldered together between two of the 90-degree PCBs are broken up into a bunch of chunks so that they're easier to heat up and adhere the solder to. So instead of just being like long runs of solder like you're going to try to lay down this super long bead or whatever. It's broken up into a bunch of spots, which helps the spot welding trick, but it also makes it easier to warm them up and just get the solder to flow at all. So really cute design here. Head on over to their Hackaday IO page because their log and the rest of it is a fantastic history of the PDP-1. Their hacker company called Obsolescence Guaranteed is putting out a book of PDP-1 graphics hacks and stuff like that. So if you want to get started programming this kind of old machine where you would, flip the switches to make the machine code, they've got a bunch of great examples for you too. So it's a combination of like history deep dive and, really cool computer examples and a really nice looking case. I think it's just a sweet build all up and down. They said they've sold like 5 kits or something. And given that there are 55 PDP-1s ever made, they're like, we've increased the number of PDP-1s in the world by 10%, which I think is awesome. But they're way underselling themselves because there are actually 3 machines still left in existence out of the original 55. So they've actually more than doubled the number of PDP-1s out there in the wild. Yeah. If you're into this kind of retro mainframes on your desktop scene, they've also got the PDP-7, 8, and 11 covered. But I think it's really sweet that they've taken it on themselves to tackle the granddaddy of them all, the PDP-1.
Well, my next hack is a video from Tech Tangents. That's no moon or Selectric. Speaking of the Selectric, which I was, this isn't one. It's a clone from Juki, who yours truly knows much better as a manufacturer of fine sewing machines.
Oh.
The Juki Selectric clone cost about $500 at the time, which was half the cost of a real Selectric. These things were completely Selectric compatible. You could use Selectric balls in them, even though Juki made their own type balls. So a Selectric cost around $1,000, in the 60s, and that same amount of money could get you a nice car. IBM actually wasn't bothered by the Juki making compatible balls or this whole deal because they were scheming to release a Wheelwriter, which I have next to me, a Wheelwriter 5, which used a daisy wheel element. As you might imagine, Juki later made a Xerox-compatible daisy wheel printer, again for a fraction of the cost of the original. Although considered a clone, this Juki is plastic and narrower than most Selectrics, save for the Selectric personal typewriter, which Tech Tangents briefly covers and drools about, as I do, in the video.
I was thinking about how easy it would be to find typewriters these days. Selectrics have to be the opposite of the PDP-1. Like, there have to be millions of them made, right?
Yeah, but are they still working or are they all sludgy?
Right.
Mine is working, but it was reconditioned by the guy that I traded several typewriters to for it.
Oh, right.
Yeah.
Yeah, I mean, that's crazy to think of a typewriter costing so much, but of course it's not. Like, the mechanics going on in there and the precision and all of that is just madness.
Oh, yeah.
And of course it would be a sewing machine company that makes a typewriter ripoff.
Well, they were already making Olivetti typewriters at the time. So.
Oh, right. The fancy industrial sewing machines that do everything are also one of those ultra-precision, tiny parts mechanical machines.
Oh, yeah.
So it kind of makes sense. Well, last up from me this week was another controversy of sorts. The weekend before was WHY 2025, which is the Dutch hacking camp. Every 4 years they have a camp. The badge for it is this really cool device. It's got a keyboard, a screen. It's a sweet little computer. It is also a little bit power hungry because of the CPU and screen and uses 2 18650 cells. And that's where the controversy starts. So this is a write-up by Jörd of some of the design problems with this device and basically how this battery was a bad choice for a device that's going to be in the hands of sweaty hackers wearing lots of metal, completely exposed back with 2 big old batteries on it. The WHY folks took steps to mitigate some of these problems, mostly because of this report, and then some of them were kind of it's up to you to take care of yourself. As far as we know, there were no incidents. So, good news all around, right? But basically the issue is on the back of the badge were two holders for 18650 cells, and you'd plug the batteries in. The 18650s were unprotected cells, which is to say they didn't have an overcurrent cutoff on them. No problem, there was charger circuitry and actually a polyfuse on the board from the badge itself, except actually a problem because one of the batteries is on one side and the other's on the other, which means there's a long power line connecting the two of those. And so the protection circuitry wasn't right next to the battery because it couldn't be next to both of them physically. And so that meant that there was kind of the possibility of shorting the positive and negative rail on this thing upstream of the protection circuitry, which was the big worry in Yurd's write-up. This is one of those things, and Yurd says this in his write-up as well, danger is not Boolean. Like, there are levels of risk and probably acceptable levels of risk, and where you fit on all this and what is and isn't too rough and ready is, I think, a neat conversation that we should have in our community. Because if this were a consumer gear, the rules are pretty clear. If you have a removable battery like this, it has to be in a case so that you can't accidentally remove it or short anything. It has to have the protection circuitry, but the protection circuitry has to be inside a case with it. And depending on what level of battery the thing is, it has to also be puncture resistant, and, et cetera, et cetera. For commercial products, there are kind of standards, but for hacker prototype dev kit products, there aren't such standards. And, who among us hasn't taken a dev board, put it on our desk, had something metal underneath it and shorted something out, right? Like an Arduino board, like anything we use and prototype with has exposed metal pins on the backside. If you put this on something metal, it's trouble. The trick with the badge, of course, is that it's hanging around your neck, and especially at one of these hacker cons, people have metal things on them as well, and they can come into contact. I can't remember what it was. There was a badge from a few years ago where the metal lanyard was actually shorting the badge out, and there were burning traces. If anyone can find me this link, hop over in the comments and tell me which badge it was that had the metal lanyard doing the shorting out. So fast forward, the Y team got some epoxy and covered up some of the loose big pads so that it would be significantly harder to short against itself. You still could, as Yurd suggests, by scraping some of the solder mask off some of the traces. There was, the positive and negative were real close to each other. So if you scrape the solder mask off, maybe you could short those out. At that point, it's a little bit less of a problem. Of course, others in the community stepped up and made 3D printable backs for the thing, both fancy, big, complex ones and just minimalistic ones to just keep you from shorting out the batteries. And that, of course, is a great solution. There were all sorts of ways to kind of minimize the problems here. And I do think that in the end, even though I personally, if it were my personal project, I would not have worried about the level of safety of it. And even if I were giving it to 10 friends, maybe not. But this is then for 3,000 people in a camp environment. And so that changes the stakes, and it changes this calculus that you can do. And I think it's really cool that this both sparked the team to minimize some of these risks. I think the ways they did it were pretty reasonable. But I think it's also cool that it is creating this discussion. And I think it's a discussion we do need to have in the badge community, because they point out the badges from other years. And I'm looking around me and all the badges that have pouches on them. A good number of them, the pouch is just like two-sided tape to the back of the badge, which is fine. And they have a protection circuit on it, so that's fine too. If you could pierce that capped on tape, maybe you could do something bad. But it's one of those pouch lithium polymer battery, actually. And if you put an ice pick through it or something, you'd have a very flamey day. That solution isn't perfect either. And actually the camp badge from the last Chaos Communications camp, Timon, who is a longtime Hackaday friend, he actually went and put a metal shield over the battery. And I remember that. And I remember saying to him, why? Seems a little bit like overkill, right? And he's like, well, I just don't want anyone puncturing the pouch battery. It's just out of overabundance of caution. And I'm like, well, okay, I guess I can see that. And then I fast forward a couple years later, there's this big hubbub, and I'm looking at it all a lot more critically right now. actually no super big secret, we just did the lithium ion power stage for our Hackaday badge for Supercon last week. And we've got protected cells and a back case. So we're belt and suspendering it ourselves. But I do think it's good to kind of have this discussion out in the open and say, look, what are acceptable risks and at what scale? And we're hackers. We're making small runs. We're making prototypes. We're not subject legally, probably, not a lawyer, to these consumer product laws, but we should have decent internal standards as well, and we should be self-policing, and we should do what's safe for our communities and our friends. So I'm stoked to see a discussion come out of this, whichever way it goes. I think I need to write a rant about this, get an Ask Hackaday out there, and get people talking about what their best practices are for using lithium-ion batteries, lithium-ion and lithium polymer batteries.
For my last hack, I chose Nick's LEDs That Flow, a fluid simulation business card. It's kind of a shame that we don't have a business card contest running instead, don't you think? Because this one would probably score pretty highly, I would think. For one thing, it's really, really thin. Really thin. 0.6 millimeters thin, by the way. And one of the tricks is that the battery is kind of suspended in the middle there. So most of the business card is taken up by a matrix of 441 LEDs on which particle interactions in fluid dynamics are simulated. Basically, you tilt the card and the LEDs flow like water. These LEDs are controlled by a Raspberry 2350. This interfaces with an accelerometer to detect card movement and make the water flow. And you'll see how thin it is if you watch the GIF on the GitHub page. But you can kind of tell from the picture. But
That's absolutely beautiful to watch it go too. Like, it's a really good simulation.
yeah.
It's funny, I'm going through his website and he mentions the Matthias Müller video YouTubes on 10-minute physics where he talks about different ways of making water simulations. And Nicholas here explicitly calls that out. And I have to say, those are really good videos.
I like the connector too, although it might not last very long.
My first one comes from Project Farm. Calipers, do you get what you pay for? And this is a video shootout of, I don't even know how many calipers in the end. I couldn't count them. By their accuracy, they end up getting broken down into roughly 3 groups, where even the most accurate group, where Project Farm could not detect that they were off by anything. The completely accurate group, the cheapest one in that group is $27. The middle group is all within the thousandth of an inch, 0.02 millimeters. And this group kind of spans that range, but the cheapest in that group is down at about $18. If the question is, do you get what you pay for? The answer is, oh my gosh, and so much more. Even the middle price electronic calipers these days are as accurate as the best of them used to be 20 years ago. So splurge, treat yourself to something for $20 that can measure within a thousandth of an inch, even if you don't need it. Next up, something physical, building a trash can reverb. You should go to the end of the video and just listen to the sounds as he walks around with a speaker that has a bolt hot glued to it and then some piezo microphones. He just tapes them to all sorts of metal objects in his environment, plays the sound through the speaker, vibrating the trash can, dumpster, street sign, fence, and playing the music through them. It's really great. He's doing kind of a techno demo, and he gets a really great grungy sounding reverb out of it. Tomit has a series of electrical engineering web pages where he makes a mistake, figures out what he did wrong, and then tells you about the fundamental properties of the components that lead to him making this mistake. This one is coping with disappearing capacitance in a buck converter. Capacitors normally block DC and absorb AC wiggles in voltage, but they are also derated by the amount of DC bias you put across them. So, for instance, if you have a capacitor that's supposed to be 10 microfarads when there's no average voltage put across it, if you put this at 15 volts and try to absorb a wiggle around the 15 volts mark, it ends up having about half of that capacitance. Check it out in the data sheet. There's also a frequency dependency of capacitors as well, and all sorts of kind of real-world factors where they deviate from this ideal. This is a great dive into the DC bias effect. And last up, Portal Runner. This is a hacky hack. 1 file, 6 formats. Just changed the extension. The gimmick here is that when you have a JPEG file, your operating system is going to hand it to an image viewer. If you have an MP4, it's going to hand it to a video player. If you have a zip file, it's going to hand it to a zip archive. Each of these different file types also has a header at the front and sometimes at the back, a footer, where it describes what the data is like. And so by kind of cleverly mixing and matching headers and file extensions, he ends up with one file that plays as a PNG image, an MP4 video, a PDF document, a zip archive, a PowerPoint presentation, and an HTML document. Some of these are more clever than others. Like the HTML document is you just kind of comment stuff out. PDFs have a part of their format where you can just like put arbitrary data there and then say, oh, the PDF begins here. And so that one's easy. But some of the others require some real cleverness. Go check out the video if you want to see how to make these polyglot files.
My first quick hack comes from the BICO, One Hertz Challenge, abstract aircraft sculpture based on lighting regulations. So this little circuit sculpture looks like a plane from a distance in the dark, and that's the point. This abstract build imitates the navigation lights of planes flying in the night sky, which consists of a red light on the left and a green light on the right. And to meet the requirements of our little contest, the BICO added a flashing strobe on the nose. As we pointed out earlier, the One Hertz Challenge comes to a close on Tuesday, so get those entries in while you still can. Next up is Polymat's Don't Say This DIY Diskette Was a Flop. Wow, is this thing beautiful. We love it when people build things because they can, not necessarily because they need something, and this is totally one of those times. Polymat certainly didn't need a brushed aluminum floppy disk, but geez Louise, you kind of want one too, don't you? I know I do. Polymat started by mocking up the shell in CAD and milling it on the CNC. Then it was time to do the really hard part, the thin magnetic inside guts. Unfortunately, the disk that he created doesn't actually read or write, but that's not the point. This is a journey that you don't want to miss, so be sure and check out the build video for this one. Last up comes from Tekavoo. Digital Etch-a-Sketch also plays Snake. This is an awesome modern take on the Etch-a-Sketch that uses an e-ink screen and an ESP32. The ESP32 reads inputs from a pair of rotary encoders. Not only can it Etch-a-Sketch, there's a long-awaited undo function that's accessible by pressing the encoder. It also plays Snake and Pawn.
All right, well, that brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week, Arya Voranova's smartphone hackability or a pocket computer that isn't. And this one is a rant that I guess Arya and I both share about why cell phones aren't more usable for hacker purposes. Like, in principle, it's the most phenomenal computer in your pocket, and it's got all of this great hardware. It's got a camera, it's got an accelerometer. It invites you to hack on it, but then at the same time, everything about your cell phone thwarts your attempts to hack on it. Like, it's got this absolutely locked down operating system. Sometimes you can't even get at the file system. It's hard to program for it. If you've pulled down the IDEs, and if Java isn't your thing, which unfortunately Java is not my cup of tea. I've tried to do phone apps natively, and it's just a difficult developing environment. Way back in the day, this used to be a lot less the case. In the early Android days, the file systems were unencrypted. It was easier to get root on them. There were more easily available scripting languages on them. But rather than this just being a rant, Arya is like, well, what can we do to improve the situation? And she's looking at two main things, one hardware, the other software. On the hardware side, she's not asking for much, just an I2C port. Just something that you could get your own hardware plugged into fairly easily. And a lot of you out there are saying, well, why not use the USB-C that it's got built in? You can do USB-C on the go and plug up to that. Yeah, you can, but it's so much easier if you want to make a keyboard add-on product or something like that. It's so much easier to hack that together with I2C than it is, going through all the USB-C hurdles. And I feel her on that one. I like her proposal of making kind of an I2C doohickey port, she calls it. She does say that this is a thing on the Pine phone, phones? I didn't know that. So I'm going to have to dig into that when we're done with this show. But then there's the big elephant in the room, which I think is the software side. Wouldn't it be great if there were just like a scripting language with an IDE that's kind of tailored to the functions of the smartphone already built in? And she brings up, what would be the hello world example of that, which is when a friend of yours calls you, you can blink the screen particular colors or do something like that. Like there are all sorts of apps that do these kind of if this then that or scripting functions for the phones, but it would be such an invitation to young programmers if they could program their phone to do something themselves. And I think that's where this is really the most interesting. I think something like a Scratch or something that's also integrated in with the phone's capabilities would be super cool. You could teach younger kids who've just gotten their cell phone to actually kind of master parts of their cell phone. And I think that would have long-run benefits for programming humanity that would be phenomenal. And so I really like her ideas on that front. It's funny, I wrote a rant about this back in 2018, Ask Hackaday, why aren't we hacking cell phones? And the comments in there are very similar to the comments today. So 7 years later, no progress. A couple people mentioned DroidScript back then. I don't know if that still exists. What frustrates a lot of hackers is that every new phone model comes out with new and incompatible hardware to the point that there are no open source drivers for a lot of this stuff because it's just a continually moving target, and we on our side of things can't keep up. Other people have mentioned the security features and stuff that kind of close you out of it. It's funny, somebody said but this is important for banking apps, and I'm like, but I run banking apps on my computer and that's not locked down. How is it that the apps on my phone have to be signed and I can't have root on my phone when I've not only got root on my computer, I installed the whole software on my damn computer? The mind boggles. I think the most kind of compelling arguments are things like phones are small, the screen's small, it's hard to program on them. It'd be great to have a real keyboard. Those kind of things I actually see as real problems, but not insurmountable ones. And again, like lack of a keyboard, you can still do a Scratch-like thing where you can, drag and drop logical blocks and make things move. I don't know. I think there have to be options for turning cell phones into computers again, breaking out of the kind of cell phone app / operating system walled garden and just in the normal hacker way screwing around with cell phones. And I'd like to see it too.
Well, okay.
Okay. I don't know. I mean, cell phones, it's the computer that even non-computer people have. Like, if there were any way that would be a wedge to get, I'm sorry if I'm offending anyone, normies into fooling around with computers, this is the one that's already in their pocket. It's like, we really got to get this done, folks.
For my can't miss, I chose Al Williams' The World's First Podcaster. I mean, one of us had to choose this one, right? So when was the first podcast? You might think maybe the 90s, maybe not. And you'd be right, as long as you were talking about the 1890s. That's right. Possibly the world's first telephone newspaper, Telephone Hermondo, inside of Budapest, offered what we would now call radio content over the phone. This service lasted all the way until 1944, although once radio came along, they started rebroadcasting the programming of a radio station. Now, Telephone Hermondo was the work of Tivadar Puskas, who had worked with Thomas Edison. While at first the service had about 60 subscribers, Puskas envisioned global participation at some point in the future. Now, an interesting thing to note is that the Hungarian government kept strict control of newspapers back then, but I think we can now appreciate the rise of new types of media. So Puskas spent 2 weeks proving out the concept and then asked for formal approval, which he was granted. What he didn't get was a 50-year exclusive franchise for Budapest. But then tragedy struck. Puskas died about a month later. His brother Albert picked up the reins and continued talks with the government, but oddly enough, before anything was settled, he sold the company to Istvan Popper. Popper finalized the deal, and they eventually built their own telephone network outside the regular phone system. By 1907, they had an astonishing 15,000 subscribers, including politicians and businesses like hotels. So by this point, you're probably dying to know how it worked. Well, in 1892, Puskas invented a telephone switchboard that could send a signal to multiple lines simultaneously. Al notes that there were demonstrations of similar technology dating back to 1881, that mentions the great 1888 novel Looking Backward by Edward Bellamy, and its dream of a telephone attachment in every bedchamber by which the sleepless could call up any sort of music. Al mentions other similar services in Paris and London, both of which collapsed due to radio in 1925. In the US, several attempts were made, but none were successful. Back in Budapest, their new network eventually crisscrossed the city, spanning 1,100 miles, which is impressive since there were no amplifiers at the time. Al looked at the Canadian patent, and it seems they used induction coils. And the company had very loud announcers. Seriously, they basically screamed into the microphones, and they worked in 10-minute shifts. The signal ran to the central office, then to one of 27 districts, and then out to homes and businesses. And in those homes and businesses, there were 2 earpieces, so you could use both ears or share with someone. There were daily programming schedules one could hang on the wall, and the programs included news recaps, stories, poetry readings, musical performances, lectures, and language lessons. There were broadcasts daily from 10:30 a.m. to 10:30 p.m., although this was flexible. A year of service, which included a free receiver, cost 18 krones, which was about $7.56 at the time. It doesn't sound like a lot, but that was about the same cost as 44 pounds of coffee. There are also coin-operated receivers to generate revenue. In 1925, the service opened up Budapest's first radio station. The private phone network they built didn't survive World War II, however.
That is crazy. Is this a podcast? The Hackaday commenters pick a bone. It's funny, the definition of what is and isn't a podcast has changed so much. Like, if you say it to someone these days, they expect a video. But I claim it's not a podcast unless it's an RSS feed that tells you where to download an MP3 file that then your podcast reader can go download for you so that you can listen to it later when you're out and about. Because wherever it is you're out and about in the 90s and early 2000s didn't have internet, unlike today where everywhere does. Best title for this article comes from Senile Data Systems. Radio killed the telephone star. That's awesome. Fantastic. Streaming killed the podcast, but not here at Hackaday. I will point out, you actually can find our RSS feed and automate the downloading of our MP3 every week if you want to. Download it to your iPod Shuffle so you can listen to it at the beach or something.
Beach. On my shuffle.
If you can find a place without cell service, you could listen to it there.
Have you read Looking Backward? It's a good book.
I haven't, actually. What's it about?
It's just like it's a book full of predictions, basically. It's just prediction after prediction.
Turn of the last century's futurism?
Yeah.
Cool. I mean, it's kind of right. I mean, the idea of a telephone in every bedchamber that you could listen to whatever music. We've got that. It's just, you know. Ironically, it is our telephone, too. Who would have thought? Huh. Well, that wraps it up for this week's Hackaday Podcast. Thanks very much for listening. If you want to follow the links, they are at hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
keep on hacking. Podcast is a very, very, very fine cast.
Okay, we'll just play the sound then. Roll the sound. Oh my god. I can't believe you picked this one.
It's crazy. I like the, well, I'll say it in a minute.
Whatever they are. What are the receptacles? What's the word for that? Holders. That was a long ass rant. I guess I should pivot to say, before I do that, rewind.
Politicians.
Oh my god, we both picked telephone hacks.
Whoa.
Half the number of the beast.
Beast. Time to go downstairs.